Okay. All right. Okay, ladies and gents, thank you for joining us today. Just to give you guys a heads up, this session is being streamed and recorded for the students at Lakehead. Lakehead University. All right, so just to let you know that there is recording happening in the room. So my name is Jesslyn Kathryn, and I'm a teacher at in Halton District School Board at Garth Webb Secondary School in Oakville. And I'm Catherine Wheeldon. I'm also in Halton. I work at Dr. Frank J. Hayden Secondary School. Okay. And I'm also the curriculum coordinator for STAO. I mean, communication coordinator for STAO, whatever. I do something around here. So we're gonna walk you guys through like a sampling of some of the grade 9 and 10 demos that we have available to you guys, and just sort of show you like how everything's laid out and what you can sort of do with the materials available to you. So all of the demos that we're showing you today and all of the demos that are online are open to the public. And part of what we'll do today is just show you where to find everything as well. Yeah. Yeah. Okay. If you do want access to any of the files that we're showing you today, this is the Google shortcut that will take you there. So this presentation, any of the MSDS sheets, there's a white handout that has all of the grade 9 and 10 demos on there. There's also the Google Doc with the links on there as well. I think we're also planning to put all of our other demo sessions in this folder as well. So if you teach senior bio, senior chem, senior physics, we're planning on dumping all that into that folder as well. So you guys bio is already in there if you're looking at it right now, like if you're digitally following along. And we also have some little paper strips up here with those links if you want to look at them after the presentation, okay? Okay. Yeah. Oh, actually, also, because today is Remembrance Day, at around 11 o'clock, we will take a minute for a moment of silence, all right, to remember our veterans. So the goal of our session today is to, again, show you some of our demo collection for grade 9 and 10. We're going to walk you through all the information, just like how it's laid out, because there's a lot of specifics about safety, MSDS, and even curriculum extensions that you can do with it. So all our demos are available in both English and French. As you can see on the handout, there's like a plethora of different activities for all the different strands in grade 9s and 10s. It is broken down into biology, chemistry, physics, and then the topic of earth-space science covered in grade 9 and 10. And there's some cool teaching tips or extensions that you can do with the kids as well. So part of our demo collection is to model the best safety practices. So like what we'll show you today with some of our activities are things to keep in mind, like paying attention to any of the hazardous materials. Like one of the demos we're going to show today does use like concentrated hydrochloric acid, and what sort of safety techniques you need to account for that. So there is also a common format for all the activities. So if you use one, then that format will also follow through with all of the other activities as well, right? Okay, so this is an example of one of the activities that we've done in the past. So last year we actually went through this activity called Invisible Ink. It is available online, so you can actually take a closer look at it if you want. If you notice, within the top of the handout, there is a course strand, so it tells you what course it relates to, what strand it relates to, all right? What specific topic it's going to go over, the time allocation, so how much time do you need to prep, how much time do you need to actually run it, so then you can sort of plan out how your class is going to go. And then it also goes over the specific curriculum expectations for each course. So in this case, there's the grade 10 academic, but then there will also be specific expectations for the grade 10 applied. With each demo, there's also an introduction as to like what topic are you covering, all right? Like why you would want to do this with your class, what materials you need. So if you actually follow the materials list, which is what we did in order to sort of get ready for all of these demos, it accounts for everything you need in order to run the activity. The big thing to pay attention to is the safety considerations. Anytime you have a chemical in the classroom, it is your legal obligation to have the material safety data sheet in your class. So on the tables in the room, you'll see that we've printed off the samples of the different demos that we're doing today with you guys. And with each demo, the MSDS sheets have been attached, all right? Now, I've shrunken it to sort of save some trees, but you have to make sure that that's in your classroom before you actually run it, and that you've actually worked through this demo before actually running it in your classroom. All right, so all of the activities, if they do involve any chemicals, will also have the hazardous materials rating system. So like, for instance, if I'm using hydrochloric acid, it will indicate any safety considerations that we need to keep in mind, but you still need that MSDS sheet. And then there is a specific procedure that walks through the predict, explain, observe, explain process, so that like you as a teacher sort of know how to run it with your classroom. Okay, so this these are the different demos that we are going to do with you guys today. So we've tried to take a sampling from both grade 9s and 10s, sampling of demos versus activities. And if you notice, some of these guys can double up as a demo or an activity, depending on how you run it and what materials you need. You can scale it back if you want students to do it individually, or if, like, for instance, elephant toothpaste, I'm doing a large quantity because I'm doing it as a demo. So if you are following with the slides presentation, all of the materials with respect to the actual procedures are linked. So you can just click and follow along if you want to do that with your device. Cool. All right, so we are going to start off with the disappearing beaker, all right? Anytime you deal with any kind of materials and even glassware, safety equipment is really important, particularly goggles. And we do have another demo talking about the importance of safety goggles, because unfortunately we can't replace our eyes. So we'll go over that in a second. So disappearing beaker. This all right. So disappearing beaker relates specifically to the grade 10 strand of optics. So you're looking at like the refraction index of different materials. So there's a really cool case of vegetable oil and Pyrex, all right? So the one big thing about this lab is you have to use Pyrex glass. If you don't use Pyrex, then the whole thing sort of falls apart. But you can use some of those other aspects as sort of inquiry pieces with respect to like getting the kids to sort of think about the materials that they're using. So what we're going to do is we're going to have two beakers, one in the other, all right? And the big thing about some of these experiments is if the kids don't know what's happening, it's magic. And then if they actually do know what's happening, then it's now science. So that's one of the things one of my colleagues sort of told me, and I'm like, oh, that's pretty true. Yeah. So let's do a little bit of magic, all right? So the reason why I'm wearing my safety goggles is if anything happens with respect to the glassware, my eyes are still protected. So even though, like, if you look at the materials, they do look pretty safe. It's vegetable oil, it's just some glass. Accidents happen, right? So it's always better to be safe than sorry with your students. So the way this is going to work is you can ask your students. So what do you think is going to happen when I pour vegetable oil into this beaker? Any guesses? Anyone? Disappear. It's going to disappear because that's what I told you is going to happen. So in this case, let's take a look. So I can still see that beaker. Oh, sorry. Is it easier to use that? I don't know what's. Where did it go? Oh my goodness.
Does it work with any vegetable oil?
Yeah, so this is just, yeah, I believe it works with any vegetable oil, but again, this is why you would demo it ahead of time, just to make sure. So like that's pretty cool. It's like, it's gone. But if I actually flip it around, you can actually see the gradations from the glassware, right? So, which is why I strategically hid it from you guys when I was pouring it. All right, but I mean, would it still work with, would it still work with the test tube? Should it? Someone says if it's filled. So, well, let's take a look. If I actually put a test tube in it that has air or that's not filled, can we see the test tube?
Yes.
Absolutely. What's going to happen when I do this?
Oh, that was a good reaction. We didn't even prep that.
All right. Now, will I get the same effect if I use water inside the test tube? Now, the question is why? That's a big thing with the students. So why wouldn't it work with water? Different refractive indexes, right? So if I do this and we do, oh my goodness. Water, right? We can still see that test tube. Cool. So, I mean, you can vary the activity, right? If you want the kids to try this out on their own, then you can give them sort of smaller materials, smaller quantities. You can also get them to test different materials. We said it has to be Pyrex. So what happens if I use actually this is a Pyrex glass, but what if I use, let's say, like a Mason's jar or a plastic cup? Will those materials still work the same way, right? So this is where you can get them into that sort of inquiry thought process, like what materials work, what doesn't. So
yeah. And different colored oils, like you were asking, does it work with different colored or different oils?
Yeah. So
try a dark olive oil,
yeah.
Or try something else, and just go nuts with experimenting.
Yes. Cool.
It's a pretty fun, safe one.
So if you guys want me to pass this around? You guys want to look at it? Is that what you guys? Sure.
Don't spill it.
Yeah, just try not to spill it.
Make an awful mess.
Okay. So the next demo that we're going to show you guys is the really big one that makes a really big impact with students is why do we make them wear safety goggles? I don't know, well, if any of you guys are pre-service teachers, then you probably haven't experienced a lot of this yet, but I always have to spend the time telling the kids, goggles are for your eyes, not as like a head accessory, right?
So that in the labs.
Yeah, it's not a fashion statement. So why is it that we make such a big deal about wearing goggles? So this is where this activity sort of hits home for the students because what we're going to do today is mimic what happens when you get an acid spill in your eye, all right? So, which means I need an eye right over here, okay? So hopefully you guys can see this. Is that okay? All right, so we have an eye. I need to now mimic the material that is in the eye, which is where the egg comes into play, all right? So we're gonna have egg. I know, I'm gonna just go. Yeah. Gloves are really important, all right? So a few safety considerations for this activity. One, this is a demo only because you will be using 2 molar hydrochloric acid. This stuff is super acidic, super caustic. It will burn your hands pretty quickly. The last time I did the demo, I had a little bit of spillage and I didn't realize it, and my hands were burning pretty quickly after, all right? So you wanna make sure that 1, you're wearing the protective equipment to keep you safe, and 2, there is absolutely no need for a junior class to be using 2 molar hydrochloric acid. All right. We do have other activities that you can do where they use acids. They can use 1 molar, which is more than enough for a junior grade. Once you go into senior chemistry, that's when you need higher concentrations in order to catalyze certain reactions. But that's a really big thing to keep in mind is like what is necessary, right, in your classroom. Because if it's not necessary, then you don't need to use it because that's how accidents happen. All right. So we don't need this yolk. All we need is the white. So what this is doing is we are mimicking the whites of your eye. All right. And unfortunately, once you do damage to your eyes, most of the time it's irreversible. So what we're doing with this demo is demonstrating that. All right. So with your class, what do you think is going to happen when I start dripping in like highly concentrated acid? What's going to happen to the egg white?
Denature your proteins.
Denature your proteins. That's a very like advanced description. All right. You might get that in your class, like for some of those keen students. Now, if you denature your protein, can you undo denaturing? Unfortunately not, because we're chemically cooking our egg. So let's see what happens. See anything happen right away? Maybe not instantly. All right. Now, if you are reading this procedure, it does say use a fair bit of acid, and the purpose of it is to show the kids just how quickly this reacts. All right. And if you notice, I'm intentionally using a colored piece of paper because in the past I have used white paper, and then the only issue is you don't get that contrast, right? So with a colored piece of paper, in this case like a really deep orange, you can actually now see that denaturing happening really easily, right? So you can even put a little bit more. Like this is just giant accident that just happened in your classroom, right? What happens when you're not wearing goggles? So what's happening to the whites of the eye? They're reacting, they're denaturing, right? And we can't undo this. So then if you start rubbing your eye, that really doesn't look so good, okay? And I mean, I'm not gonna put any more acid because I still have to dispose of this, but in your classroom, if you wanna make that even more apparent, you can add more acid to it. Just make sure, like for disposal purposes, that you are very careful with the disposal. Neutralize it ahead of time. Like I have a beaker or a bucket of baking soda water, so you can just sort of dump that on, neutralize it before you dispose of it. All right. So we'll leave that there to just sort of let you see what happens as we continue on to the fun science. So what's next? That's a really good question. All right, dancing paper.
All right, so at your tables, you have some rabbit fur. You have a piece of polyethylene tube or strip or whatever. And then you have a little plastic petri dish. You can use glass as well, although I find glass is harder to come by in science labs these days, with some paper inside. So leave this closed. Rub your polyethylene strip pretty vigorously with your rabbit's fur. And if it's kind of threadbare, because the kids have been a little aggressive with it over time, you can try to make sure it's actually on the fur part, okay? So rub it, rub it, rub it, rub it. And then, yeah, just, you're going to get those comments, just deflect. That's all I can say. Just say it's all in the name of science. So hold up your, like, keep this as flat as you can. Oh, it's funny, there's static in this already, so it's sticking. Without touching your petri dish, that's a pretty key component. Bring this as close as possible if you can without touching, okay? And you're just going to kind of like make the paper dance by moving it around. Okay, see how much you can move it around in the thing. If you accidentally have your plastic petri dish, you'll probably lose your charge, okay? So then just go back to your fur, charge it out. The other thing is some of these petri dishes might be a little bit too cold. So if you're not getting that kind of dancing effect, you can take some paper out. You can take some of the little
There you go.
and you'll get a more evident effect, because if there's too much paper, there's like
That's so
too much or not enough space in the charge to actually move around. Yeah, so let everyone here in a large group trying this out. You can also try different variables. So I would recommend in class
doing with the students, you tape these shut just so you don't get big paper messes all over it, because it'll stick right to the rod, which is fine. You can do that too, but you're not gonna get that nice motion and movement of the paper moving around. You can try different materials in here. So you could try putting pepper or something else. Although if you're using a small particle like pepper that can be inhaled, definitely make sure it's taped shut, okay? So the kids can't open it up and mess around with it. Because it'll not only make a big mess, but you don't want people to inhale that. Look at your electrostatic series. Having so much fun with this. Look at your electrostatic series and try out different things. So if you're looking at the actual demonstration and activity handout that STAO has produced here that's part of this lab, it actually says to use wool over like the fur. We had rabbit's fur available at Jesslyn School, so this is what she brought with us. Fur is actually even better for it. So if you have access to fur, some labs have taken it out just with allergies and everything. They figure, like, why have that around? But it works even better if you have fur over wool. And then you can try all sorts of different materials too. You could say, well, what happens if I rub silk on it or cotton cloth or something? And that's where the kids can have a lot of fun with changing up the different variables and trying out that electrostatic series with different materials and trying to charge things up in different ways. There's obviously there's lots of other types of electrostatic series labs and demonstrations you can do. You can do the bending water one. I don't know if you guys have seen that, but you turn the tap on as slow flow as possible, but it still has to be a complete flow of water. It can't be dripping. And then you charge up your rod and you bring it near, and the water actually bends, and it's kind of exciting.
Yeah, so, or even bends towards, depending on what the charge is.
Exactly, and what materials you're using. So simple, pretty cheap. Almost all science labs have like this kind of material. Sometimes you'll see like acetate strips, like the flat ones. Sometimes they're colored, sometimes they're clear. Ebonite rods. Like there's all sorts of different materials, but we just brought this in as like one little quick demo. That's a fun thing to do with that. This one's kind of gross, but you can use human hair to charge, because human hair is just kind of along the same categories as wool and fur and all those other things. It's human fur, if you will, I guess. So yeah, if you wanted to use that, you could, as long as it's not touching anything else in the lab area. So you guys can continue to play with that while we're doing some other activities today. So do you want to show them the egg again?
Yeah, so since you guys got distracted with the fur and the empty paper, this is where our eye is at, all right? So if you notice, it's gotten pretty chunky, all right? Which, I mean, is like a major deal when we're dealing with like students' eyes, right? So this is that sort of like impactful statement that you want to make with your students. It's like, you can't undo this, right? So make sure you wear your glasses. Like when I'm running a lab, regardless of the lab, I'm super strict with my students, just because it's not worth the safety of me or their classmates if they're not being safe, all right?
I just wanted to add to that one time when I was a much younger teacher than today, I was teaching the weather unit. So back in the old curriculum, it was grade 10 applied, teaching weather. So I was in a shared classroom where I'm only in there one period a day and other people are using it. So the point is that I was not doing a lab, okay? We were doing like pen and paper stuff that day. I grabbed my attendance at the end of the day and I walked down to the office. By the time I got down there, I looked at my hand and said, oh, I don't remember getting whiteout on my fingers. And then I said, oh my gosh, I don't remember whiteout burning and hurting people. So what had happened is I had touched what I can only assume it was concentrated hydrogen peroxide, and I was getting a chemical burn on like all the pads of my fingers. If I had rubbed my eye, this kind of thing would have happened. So that was a very super scary moment as a young science teacher. Like, I can do everything I can to protect myself with my own personal protective equipment for my labs and everything that's going on. But that is a great argument and support to tell students, this is exactly why you cannot eat in a lab. You cannot drink in a lab. You can't have that piece of gum in a lab. You really can't break the rules, even if today your class isn't doing some sort of lab or experiment. Because in those shared classrooms, which you probably have all experienced, you just don't know what's happened in the period before. I still do not remember even touching wetness. Like hydrogen peroxide, if it's out of the bottle, is clear, odorless, colorless. You just wouldn't know. It must have been a tiny amount on the tray or whatever I had touched. And it was a big almost. I am pleased to say I have feeling back in my fingers, and I did recover from that, but it was a very super scary, like almost moment. So feel free to share that story with your students to scare them into not eating and drinking and that sort of thing in the lab.
And I mean, like with most of your major caustic materials, they are clear, colorless, odorless liquids that look just like water, right?
Yeah.
Like concentrated hydrochloric acid and concentrated sodium hydroxide, like they look all the same. So like you have to be very like aware.
And so that's another reason why, say you did come into a lab and you saw what you thought was water on a lab bench and you thought, oh, I'll just clean that up with paper towel. Don't ever do that, because if it were acid or hydrogen peroxide or something else, like make sure you put on gloves and then clean it up with whatever, like paper towel, or dilute it first, or ask somebody else who's more experienced if you're unsure of how to clean it up. Just always err on the side of caution, right? Because like, why take chances when you don't need to? Okay, sorry, tangent.
Cool. All right, so we are going to move on to a demo, which you can like adjust to be a student activity in your classroom for grade 10 applied or grade 10 academic chemistry, all right? So this activity is called Elephant's Toothpaste. So the idea is that it's gonna link into the chemical reactions, getting kids to sort of talk about like what is there or what evidence is there to indicate a chemical reaction, and then we can sort of talk about what's happened and how we can extend it. So the materials that you need to use for this is 6% hydrogen peroxide, right? Now, if you've looked on YouTube, like this is a really common experiment that people do, and a lot of people want to have the wow factor, where it gets sort of explosive. And in order to get the explosive kind of situation, you need to use concentrated 30% hydrogen peroxide. As a teacher, I personally don't think it's worth the possible hazards of doing that in the classroom. Yes, you get a really cool effect. Yes, the kids get really entertained by it. But as mentioned, like Kathryn's already dealt with the situation of concentrated hydrogen peroxide. It burns instantly, right? So is it really worth the hazard of having that when you can still get the same effect in a safer manner, right? So that's always something that you want to keep in mind. Like I've had conversations with my colleagues. They're like, oh, like you can like do all of these other cool experiments that like get the kids really like wowed. But then it's like, yes, but the big but is if it goes wrong, it will go horribly wrong, right? So always keep in mind those safety factors. Sorry for the tangent. The way it's going to work is you're going to start off with 100 mils of hydrogen peroxide. Yes, 6% hydrogen peroxide. All right. And then in another beaker, so I've already measured out like 1 packet of just dry yeast. I use just like the traditional stuff, and it just needs to get woken up with a little bit of warm water, so about 60 mils. All right.
Warm, not too hot.
Not hot, okay? So you don't want to kill your yeast because they are living organisms, all right? The purpose of it is just to wake them up. And the thing is with this demo, the yeast actually is not part of the reaction. They are acting as a catalyst. So I'll run the demo and then we'll sort of talk about what happened. So we're gonna do 4 drops, 2, 3, 4, one's a good measure, right? And a little bit of food coloring. Oh, the blue's a lot nicer. Okay, cool. And what we're going to do now is we are going to quickly dump the yeast into the hydrogen peroxide. Does anyone have any idea what's going to happen? Foam. Woo. All right.
I like the blue cascade.
I know, the blue cascade. It's cool. The red really didn't show up.
No, blue, so I guess darker food dye
Yeah.
works better for this
Now,
one.
I don't know if you guys can notice. Does anyone see the steam coming off of it? So this is like an exothermic reaction. So like it is like very warm, all right? What just happened with the hydrogen peroxide? Anyone? Broken down, all right? So this is where you can start talking about like the different kinds of reactions. This is a decomposition reaction, all right? The one big thing to mention to your class is the yeast is not part of the reaction. It's a catalyst to just help it along. All right, hydrogen peroxide, if you actually leave it on the table, will naturally break down to water and oxygen. So the yeast is just pushing that significantly faster. And then you get this reaction. Now, what is technically in all these bubbles? Oxygen. So as an extension, you can start talking about gas tests that they would have actually done in grade 9, right? So could we technically test the presence of oxygen? Absolutely, right? They can take a glowing splint, put it in, and then you'll actually see it reignite. So you can do this on a smaller scale, like smaller quantities, smaller test tubes. If you notice, it does get a little bit messy. So that's one thing. The other thing you can do is you can do the same experiment minus the dish soap.
So this is the 1 minute of silence. Okay, sorry. We're just
Attention. In honor of our Canadian soldiers who made the ultimate sacrifice for our freedom, we ask you to join us in recognizing a moment of silence for Canada's Remembrance Day.
I don't think they're going to tell us. Thank you.
Thank you.
I was like, all right. Where was I at? Yeah, did I finish? I think I finished talking about this. Any questions? Cool. Yeah, so you can do this on a smaller scale. You can do it without the dish soap, and then they'll have an easier time sort of doing the gas test with that.
Yeah, because then
You don't get all the bubbles. Yeah. Cool. All right. Moving on. I think we are on to air pressure.
All right, this one's fun. Also could potentially get messy, so just be careful. This one involves the water in your buckets here. So there's one group. If you guys just want to disperse to the other groups, you can just even stand. It's okay. We've put little cups in here so you can try out different things, and we've put bigger cups. I'll just hold this one up to show you what I'm talking about here. So one cup has, it's not full right to the brim, and one cup is full right to the brim. These index cards will just barely fit over these, okay? Obviously, they fit over the small little shot glass ones a bit easier. So what I'd like people to do, hold it over the bucket so we don't spill stuff all over people's electronics and papers. You're going to take your paper, okay? Your index card, I should say, and I'll do it with the more full one actually. You're gonna hold it over your bucket so you don't spill. Hold it firmly, but don't squish down on it, okay? Like don't squish it so it's bending into the cup, just hold it so it's flat. And you're gonna flip it over gently without being too aggressive. And then once it's totally flipped over and your hand is there and you're supporting it, you're going to gently remove your hand and ta-da, magic, like Jesslyn was saying. If you don't know the science, then it's just magic. But we will explain we will explain the science. So I'll let you play around with this for a few minutes and then we'll chat about what's going on. So the key with this, so it doesn't sploosh, just so you know, don't like aggressively move your hand away, okay? So do it nice and gentle. You can reuse the wet cards over and over. Try the little ones. Get other people in your group to try it.
Yeah.
Why not?
Do it.
We definitely do that.
You can do it. You got it. You can't even reach it.
Can I try the little shot glass?
Do the fuller one.
Oh yeah, let me do that one. Does it have to be full reach?
I don't think so. No. Because you need to air it.
The more air, the better. The better it's going to work.
Yeah.
More air is better?
More air is going to work better.
I trust you, the pressure. I trust you. You understand the science.
He understands the science. It's not just magic to him. Yeah, you got it. You got it.
There you go.
Yeah, yeah. And now this is where you take your hand away.
Yeah, exactly.
This water is terrible.
For now, it does.
Who's
Okay,
gonna
so
do
it's
the
ice
fuller
is the
one?
problem, not the water.
It's the extra coat. But I like that.
Yeah, I love it. I love it. Pretty much sums it right up.
Yeah, and one of the reasons why I think my last is that it's actually like how do you feel about like no, well, like some
If you want to use the concept.
Okay, so now that you've had a chance to play around with that, water, this one again, I like to call these things dollar store science, right? Because I literally purchased all these things, including the bucket, at the dollar store. So what's happening with your water and your piece of paper or your little cardstock on top here when you flip it over? Like why does gravity not kick in here and make our water sploosh out? Does anyone know this one? Has anyone done this before? Yeah.
The air underneath is pushing up on the card.
Yes, because we have taken the air out. This is full of water. I mean, there's a little bubble of air in this one. There's more atmospheric air pressure outside of the cup, and so therefore it is pushing up on the card with a stronger force than gravity is pulling down on the mass of the water that's inside the cup. The cool thing about this one, with making modifications and letting kids experiment, like yes, you can do this as a teacher demo at the front. You can explain those things for the very eager kids that are like just again too aggressive with like the paper placement. With this, that you do have to like kind of be gentle, or you'll pull the paper off accidentally. But you can experiment and change. So that's why I gave you a cup that had a little bit of air space in it, okay? And then one that's full right to the brim. It works best if it's full right to the brim, almost to the point where it's overflowing, and when you put the paper on, it splooshes a little bit. If you have a bit of air, then you're actually getting a little bit of air pressure inside your cup as well as the atmosphere. And so then the differential between the two isn't as great. So there will be a threshold at some point. How much water can you have in here with air where it's not going to work anymore, which is kind of a fun experiment for the kids to work on. So sorry, that was the Remembrance Day alarm, and I didn't turn it off properly. So yeah, this is again a neat one you can modify. Let the kids do it again. Do it over your lab sinks, okay? Not even over the benches, because it's gonna make a big old mess and water gets slippery on the floor. Fun, simple, easy, cheap, really good to do with the kids. Okay, and this one is for grade 10 climate change and air pressure. All right, cool. Next one.
Last one that we have on here is predators and control.
Oh, okay, that's me again. So this one, just so you know, when I did this for this room and this situation, I downscaled it. We think it's actually a little bit more fun and better with your class to use the actual dimensions that they said on the assignment. It's just we have lots of people in this room, so that's why I made it smaller. So this is representing your forest community. Your little brown squares are representing your rabbits, and your little orange squares are representing your fox population. So if you want to take out 3 rabbits and randomly throw them onto your green forest environment or environment where your rabbits are living, just toss them on there. You can do this on the floor if you're using the larger scale pieces with the kids. Okay, so we have our rabbits, and again, just spread out anywhere, it doesn't matter. In fact, don't do it strategic. They're just randomly in this environment. Now take 1 fox, 1 orange square, and without thinking about it too much, I mean, make sure it lands on the green, but throw it, see if it falls on, okay? Look at where your orange square landed. Unless you happen to be really lucky, if you want to call it that, you probably did not have your orange square touching all 3 pieces of brown, right? Did anyone have that? Okay, so in this simulation game about population dynamics, what this is representing is that the fox, your orange piece, has to be touching simultaneously at least 3 pieces of the brown, your rabbits, in order for it to survive and reproduce and move on. Okay, so probably no one was in that situation. So leave your rabbits there, but take your fox off and add 3 more rabbits, because the rabbits are able to reproduce and they double in population because rabbits like reproducing. So throw 3 more on randomly, not like no pattern or anything. And throw a fox on again, showing that a fox is coming into the environment. All right, so you may have gotten closer, but you maybe still aren't there yet. So for a few minutes, just keep trying this. When you get to the point where your fox, your 1 orange square, actually is touching 3 brown pieces, then that means the fox was successful and it will be able to reproduce. Okay, so then you put another fox on and another fox on. So try it just for a few minutes. But it still come out.
That is one unsuccessful.
At some point, you will get this. Yeah. Well, especially with the rabbits, that's what you're supposed to do is, yeah. Well, because then eventually all of a sudden the foxes will start doing really well, right? When the foxes is not brown pieces. It may take a while.
Yeah, and like it's technically all of these guys would reproduce, right? So like, it would be like double it, yeah. So it would actually double like pretty quickly.
Because it's all heavier. Yay! Okay, so now you bring in another fox to the population. You take the 3 away that he ate. Like the rabbits, still, all these rabbits are still reproducing, right? So you'd be putting on more rabbits and then foxes. You know what I mean? It's fun. Okay, so there's lots of time to still play, but I just want to mention a couple things about running this activity. You don't have to pack it up yet. You can still play. Okay, so a couple things for running this activity with students. So if you are in a cramped space, you can do a small version of this like I've showed you today, just with like a small piece of paper and these little fiddly bits. But it's also fun to do it like if you want to do it on the floor and you have more space. Using like a piece of Bristol board for your green is probably better, and it does fall a little nicer when you're using a cardstock or a Bristol board cutout. Okay, so that's just kind of a tidbit of making this your life easier. It also makes the materials last longer. Like the kids are pretty hard on construction paper. So with this, as far as representing that predator-prey relationship, so you could even use this in grade 12 bio too if you wanted. What's happening is as the foxes are being unsuccessful at catching their prey, that rabbit population is doubling, right? But they're doubling randomly and they're being dispersed randomly within their forest ecosystem, your green piece of paper, while they're doubling. But with the foxes, as you are introducing the foxes, they aren't random because they should be going towards the prey, right? They're going to seek out the prey and try to hunt them down and catch them. So what you can explain to the kids is throw the brown pieces randomly, but try to, like without touching the paper, try to actually drop the orange pieces or the red pieces, if you do what it says in the instructions, right over top of the brown. And so you will be a little more successful more quickly with the population of the foxes increasing. So you can throw in all sorts of other elements and things with this. You could do habitat loss. So you could make little squares or circles where you throw down like, oh, housing development, we lost the population of whatever's there. And it could hit the foxes and it could hit the rabbits, right? You could throw in disease. You could throw in, you could talk about like wildlife corridors as far as habitat loss, and you put strips down where they can't cross these lines. So now if the food source is on the other side of the line, they can't access that, like all sorts of different things. So this is like really, really, really basic the way we have it set up now, but it has opportunity to add all sorts of extensions, different elements, different interesting things. And the kids actually, like, even though it's so simple, kids really do kind of like this, and it's a neat kind of hands-on way to look at it. The other aspect about this is it's a really great and simple way to get kids graphing. So if you have them create their own graph, even just on paper, that they can be tallying up how many populations or how many reproductive cycles it took for the foxes to be successful, then that's kind of interesting too. It just adds in a little element of like data collection and tallying and numeracy with your demo and lab. Oh, so yeah, okay.
So with the last little bit of our presentation, we're just going to walk you through where to find everything on the website. Now, with respect to the materials that we've given you, on the one table that's on the white sheet of paper, I have put Google shortcuts to take you directly to the part of the website that has all of these demos, all right? But navigating the website is also, useful to know. So where can you actually find this? If you go to stao.ca, at the top bar, there's going to be a tab called Resources, and you're going to go into Secondary, all right? And then from that Secondary tab, oh, come on, not responsive finger. Oops. All right, from that Secondary tab, it's then going to give you a list on the right side of all of these different resources that we have available from STAO. But specific to our demo collections is the grade 9 demo collection. And if you do teach any of the senior sciences, our grade 11 and 12 demo collections as well. So in this case, we're going to go to the grade 9 and 10 demos, if my computer, okay. And then once you go to the grade 9 and 10 demo collections, all right, you will see a table that is identical to the one that you guys have on your sheet. Unfortunately, it's not interactive at this point in time, so it's just a list of the different demos that are available. Then on the left side, you can click on the different course to take you to the specific course and the specific topic or lesson that you want to go to, okay? So that's where you guys can actually find our demo collections from STAO.
There, you'll just notice up there, there's all sorts of other things like safety and food safety if you happen to need that for some reason, and there's other specific demos like astronomy, electricity for grade 9, other ones up there that are great. So this is kind of like your one-stop shopping for what you're looking for hands-on demos and activities for your classes.
Awesome. All right. So that pretty much concludes our presentation. If you have any questions for us specifically, these are our email addresses. If you've taken down the web link, I'm just going to scroll down to the next slide. Link to today's files, which includes this presentation and our contact information. You can get it there. Please share your feedback. We would love to hear from you guys on any kinds of improvements or what you like. That would be great. All right.
Thank you.
So thank you.
Here, we also have. Thank you. We also have, if anyone's interested in becoming a volunteer STAO, we're always looking for fantastic, energetic people. So please come talk to us. You can scan this QR code, or there's a shortened URL at the bottom that you can get the volunteer application. And feel free to come up here and grab some of these things. These are also in the playground, but we've shortened links to the specific courses. So like this one's for physics. We have biochem. There probably isn't enough for everyone, but these are all in the playground if you haven't been there, which is located near the exhibitors hall, I think in Paris or New York, right? So check it out there.
And if there are, because I realize there are a lot of you guys, if some of you guys weren't able to get the one handout that has the links for the grade 9, 10 demos specifically, there's some cards that have the Google shortcut as well. Okay. So thank you for. Oh, yeah. Okay. Thanks for coming. Bye.
Thanks.
Bye.
Thanks, Kathryn. Good to see you. Bye.